This is a video in the series of videos that describes how to compose the behavior of units by attaching models to them. In this video, we're going to take a look at Flame's airspace models. In the previous videos, we have attached platform, cognition, sensor, data processor, subsystem, weapon system, and munition models to this blue shooter, and so that it now has enough capability to be able to detect this enemy truck and make the decision to engage that truck and launch a missile, and a missile will fly and engage and destroy the truck. What we're going to do now is add just a little bit more sophistication to the process of identifying targets and selecting targets. So rather than just using the range of the sensor and the range of the munition to detect a target, we're going to use an airspace model. So in Flames, an airspace model is an environment type model, and the parameters are edited here underneath the environment menu here. And an airspace model is intended to represent a point, a line, an area, or a volume in space. So all it does is store the geometry of one of those types of objects. It doesn't have any behavior associated with it. It doesn't cause anything to happen in the scenario, but the airspaces are used by other models. So here's some examples of airspace models, and this type of model, like most other models in Flames, there is no airspace model built into Flames. It's a base class that you can inherit to build your own airspace models. And in the tutorial models, we only have one airspace model. We just call it FVX zone. It's intended to represent some kind of a zone, some kind of an area in space. And it is a circular zone. It has a radius and then a latitude, longitude value for its to locate its center. So it's just a circle somewhere out in the world. What we're going to use this for is to limit the area in space, or the area in the terrain where we can search for targets. So we're going to restrict this shooter to shooting only targets that lie within this particular zone. So before I get into that, let me tell you a little bit more about airspace objects. In the starter models, we have several more classes of airspace models. We do have zones, but the zones can be defined by a polygon in addition to being defined by a circle. And we also have transit routes, or you might say transit corridors. So we have ships that can move through transit corridors. We have fixed-wing aircraft and rotary-wing aircraft that can fly through corridors. And so if you're having, say, a low-level transit route or an ingress or egress corridor, you can use airspace models for whatever you want, and the code that would use that is implemented in some other kind of a model, usually inside of a cognition model. So again, as I've mentioned several times before, the tutorial models are very, very simple. We're just trying to illustrate the types of models that we have in Flames and the ways that those models can interact with each other. So that's exactly what we're doing with this zone. So let me show you how we can use it. So I'm at the scenario that I had at the end of the previous video, where we defined a weapon system and munition model. And this scenario is defined such that, again, so this shooter can engage the red truck. And as we already talked about, it's basing it on the range of the sensor detection capabilities, and the range of the munition. So we have in this scenario already loaded this one zone, and right now you can't see it on the map, but the first thing we're going to do is change the display preferences to be able to display it. So we're going to go over here to View Preferences, and there's other videos that talk about view preferences, so I'm not going to give you a lot of detail about that. But the main preferences for the 2D view, and these are the drawing capabilities that are built into the 2D view by Flames. They have this option to be able to display airspaces. So when I check that box, this particular airspace is drawn. And this box lists, this group box area lists the classes of airspace that are registered in this particular Forge instance. So in other words, the airspace classes that are in the tutorial plugin, component plugin. And we only have one, as we saw from the airspace window right here. There's only one airspace class. So you can turn the airspaces on and off. And the way that this gets drawn is by code in the airspace object itself. One of the methods of the airspace class is a 2D drawing method. And so the developer can choose to implement that method or not implement that method. If the method is not implemented, then turning on this drawing, this box would not have any effect. The airspace would not show up. But this particular class does implement the 2D draw method. And it's drawn here. By the way, you can draw in the 2D view. You can draw in, there's a lot of different places where you can customize the 2D view and put your own graphics in it. And this is one of the many places where you can do it. So in the part of the overall refresh event of the drawing, if I have that box checked in the view preferences, all the draw methods of all the overlay or all of the airspace classes that are, and I can actually turn certain classes on and off here. If I've got several different classes and I don't want to see all of them, I can filter it just a little bit. So if I'm a member of the class for which drawing has been enabled, my draw method gets called, and the way you draw in this 2D window is using OpenGL. Flames draws all these other things in this window using OpenGL, and so you have an opportunity to do your own drawing in this window as well using just straight calls to OpenGL. So this zone, again, just defines a circle, and we can change the location of that circle if we want, and I'm actually going to do that now. I'm going to take this particular airspace, I'm going to make my own copy of it, and you should know how to do that now. I'm going to create my own data set, and I'm going to accept it. So now, as the output says here, it just created a copy of that airspace object in my own data set. So now I can change it, and I'm going to just change its position like this, and I hit accept, and it just shows up at a different location. And by the way, there's the source code for this user interface is there too, as well as that button, so you can learn how to do pick coordinates from the screen in your code as well, just by looking at the source code to this class. So that's the airspace. And again, the airspace doesn't do anything in this scenario by itself. It requires the models to actually be aware of that airspace and do something with it. So by default, our shooter doesn't depend on an airspace. But there is a command that is defined for this shooter by the shooter cognition model called assign zone, and this is one that we haven't looked at yet. So this assigns a zone within which the unit should search for targets. Only targets within this zone will be engaged. So I'm going to add this command, and it asks me for the name of the zone, and because the name is blank, it's red. And I can pick that zone from a list right here, of course, as you know, but since this button is enabled, I can also pick it from the screen. And so Flames has built-in ability to be able to do that. And so I now specified the name of that zone. So I'm going to go over here to my airspaces, and I'm going to take, well, actually, I'm going to leave it right where it is right now, and I'm going to execute. And it shoots it. So I'm going to show you. Let me remove that command for just a second. I want to show you a detail in the output. So I remove the command and it's running and it shoots. So let's go look at the execution output now, and I want to show you something here. The assess method puts a message out here that it says it detected a unit. So it says it's looking for the target within 500 meters, 5,000 meters, 5 kilometers. And as we looked at in a previous video, it got that number by going and looking at the max engagement range of the munition that was attached to this particular unit. So when I don't have a zone defined, it's limited by the range of the sensor and by the range of the munition. So I'm going to reset this now, and we're going to go back and add this command to assign a zone, and I'm going to go back through and do it again. So now I have the zone, and now I'm going to run again, and let me just pause right here. The message is slightly different. It says 1 unit detected, looking for the closest target within zone, and then it gives the name of the zone when the zone's just simply called zone. So that's letting us know that inside this particular cognition model, because we issued the assign zone command, we initiate that command, this model now knows that it should be looking for targets with that are within this specified zone. And this target is within the zone, and so as we run here, it does the engagement. I'm going to reset, and I'm going to, and we'll go out and look here. So it says engaging truck 2. So I'm going to go up to this airspace, and I'm going to move it. And I'm going to move it just by clicking a point a little bit farther north. So the airspace center has been moved. I'm going to run the scenario again. And so now we see a slightly different message. It says 1 unit detected, looking for targets within the zone, and then it says no target engaged, and that's because the zone has been moved and the target is not inside the zone. So this is a very simple example that shows one of the innumerable ways that a zone or an airspace object can be used in the processing of an engagement. It's up to you as a developer to write the classes that you would need for the points, lines, areas, and volumes in space that are important to the processing that's taking place in your models. As I mentioned, the starter models have a few more classes of zones, so you can see other examples of more complicated zones and of more complicated ways that those things are used by the models. But the code for this will illustrate one of the standard ways of how a unit can go to a zone. It can query the zone for the way this one's implemented for whether or not a point is lying within the zone. This class has a method to be able to do that. And then, as you can see here, it uses it to determine how it does engagements. So I hope this is helpful. Thank you for watching, and thank you for using Flames.